here, Dan from Molly. I'm here at the Engine Expo talking to Billy Fisher, works at Straub Technologies. Billy, the cylinder head expert here.
No.
So me and Billy go back working the NASCAR days. So Billy, tell us a little bit about some of your background to get here.
Well, I first started back in the 80s with the little teams and all that and everything, and it was hard to do development work and all that. That's what we had to do it all by hand.
Yeah.
There was no CNC machines and nothing, so we had to do them all by hand. And then as I got older, went down to Yates, Childress's. I worked at Childress for 7-8 years. I did all the qualifying cylinder heads for the 31 car, plus I did a lot of R&D work for GM.
Yep.
So the R5 head and all that stuff and the intake manifolds.
Yeah.
So when I wasn't doing qualifying heads, I had to go over there and start doing R&D work and development. And I developed the head for Everham or Mopar, the one head, the last head they had of the year. That was, I designed the cylinder head port for that.
Yeah.
And then I worked for Yates with Dan here for 4 or 5 years.
We had some good stories, but we're not going to talk about those on here. But yeah, so Billy, I'm talking about cylinder heads, and you know, everybody's want more power. What we're talking about here, and the common thing people talk about porting cylinder heads. So I'm going to come to you because you know a lot. So basically, let's talk about some do's and don'ts with a cylinder head. Of you know, when you're looking at a cylinder head, what's some of the do's and don'ts that you would recommend to people of what you should or shouldn't do?
Basically, a port will tell you when it needs. Bigger ain't always better.
Bigger's not better.
We've learned that. Bigger is not always better. Unless you put a huffer on it to take up the big difference. Bigger ain't always better for aspirated motors.
Right, okay.
Naturally aspirated motors.
Okay.
You don't want to make your seat ring too big.
Okay.
You don't want to make your bowl too big.
Okay. And what happens if things just get
dies down?
It dies down. So you
it
lose
doesn't
velocity?
have no speed, no velocity. It just becomes a stagnant port.
Okay. Okay.
Right.
And then you don't get any volume of air?
Don't get no volume. Your coefficient numbers go way down.
Okay.
And basically, if you can find a coefficient number off of a head, if you got a 1020 Superflow or anything like that, the computerized one like we use, and it had the coefficient numbers, you can put a head on there and see like a 409 CFM versus a 380. The coefficient number means the airspeed, the volume's moving faster.
Okay, so you're putting more fuel in with...
Because the air's moving faster.
Very good, yes. Okay, so how do we achieve
gets too big, it gets stagnant.
So is there a ratio of what you're looking for on a
usually about 80%.
80%?
80% of the seat ring area. Do the bowls. You blow, you know, I can tell you where to blow out and all that, but you have to basically put on a flow bench to figure out the one wall needs to be straight.
Okay.
The other wall that comes around, you can blow it out on the side here a little bit, so that as the fuel comes in, it does this number, which the port will help it pull it out and swirl effect.
Right, swirl effect. Okay. So when the air's coming in here, so you know, does air need something to hang on to?
Air usually runs around 6 degrees radius. What I learned with the old the funnel fountain manifolds, remember them?
Yes, sir.
The 4 Venturis with the tube going all the way to the bottom and the funnel fountain, you suck the fuel out of it and go in there for the restrictor plate deal.
Yeah, that was interesting times.
Yeah. So basically, it was about a 6 degree to 6.5 degree radius on the Venturi. We call them Venturis that you put the 4 in the corners.
Okay.
With the big tube sticking down in the bottle that filled up with fuel, and then it funnel fountained out because it sucked it into the manifold. Okay.
Very cool. So if you work on your seats, you're working on getting your 80%, you get some reduction here. And as far as how do you get all the, you get all this swirl and so forth, so how do we get the exhaust out? What's the optimum for getting? Basically the same. A lot of area you need to work around is right here. Okay. Just right past the seat ring on the short side. There's 2 sidewalls. Because this is actually Venturi, so as you're pushing it out, the air's going down and then it has to go out. Right, okay. So you want to squeeze it down in there and then let it go fly out. Okay. And is that kind of the same ratio that you're looking for? Pretty much same. Okay. Okay. But the cross-sectional air across the valve guide, or on the opposite side of the valve guide here, this area is what you blow out to help it form and go out. Okay. That's what I learned. And a lot of it has to do, as your chamber
you need this chamber to run directly with the top of the seat ring, like, and even not down here like this, but kind of like a nice steady flow.
Right, right. So you're getting air in and out here because we're looking at the chamber, so we're going to keep it there. So valve angles, have you seen a lot of this flow?
Yeah,
with
valve angles are very critical. Like big block Chevrolets, the standard was 45. 50 to 52 works real good on them. A lot of your LS 50 to 52 works real good on them.
Okay.
You know, in Cup we were up to 55-degree seat angles.
Yeah, took a little bit to get there, but
that's about as far as you want to go before they weld the valve to the seat. 60 degrees, we tried it, but it welded the valve to the seat and didn't do real good.
Yeah.
So we backed it off 5 degrees and it works out perfect.
Yeah.
And you got to remember too, your valve angle kind of plays in where your RPM range is.
Okay.
So the like a 30 degree, like the old Oldsmobiles and Pontiacs and all that, were 30-degree seats. They weren't a lot of RPM motors.
Okay.
The high RPM motors, you run about a 55, 52, 50-degree seat.
So you're changing valve angles as RPMs is going up.
Yeah, because it picks it up upstairs.
Okay.
23-degree heads don't like a 50-degree seat angle. 18-degree with the raised port in them and a big long short side, usually likes a 50, 55-degree seat angle.
Because you get more RPMs.
Yeah. Well, the short side has a lot to do with it. It ain't like the old Fords of a line of sight or the old big block 24-degree heads, which is basically a line of sight deal.
Right.
So anything over 52 kind of doesn't work real well.
I understand. Okay.
So that's what you got to look at too on your port.
Yeah. So we talked about this going. You mentioned short side a couple times. So what's the trick on a short side that gives it some optimum?
Short side is where the air hangs.
Yeah.
Okay? If you got turbulence in your port or something like that, usually you'll take it out of the roof to kill the turbulence.
Okay. So turbulence. Did you explain
That's
turbulence?
where it starts to spit back at you in the port.
Okay.
So what it means is it's going in there, it's hitting off the back wall, it has nothing to hang on to, so it's just bouncing off the wall and coming back at you.
Okay.
So your short side and your top roof are not aren't the right way angles and aren't got the right pitch to it, basically. So when you start to do that, the fastest way I figured out how to fix that, and it might not work for everybody, but it works for me.
Okay.
Okay, I'm going to say that up front. What works for me might not work for you, and what works for you might not work for me.
Because there's a lot of different combinations out there.
I find that if I take out of the top of the roof around a valve guide and raise it up a little bit and straight on back, it takes the turbulence out. Your numbers will come back a little bit, but you still have to figure out your short side to make the big numbers.
Okay, so you're trying to keep the air as clean running through there, keep turbulence, because when you're flowing air on a flow bench, you can hear turbulence, right?
Oh yeah, it's spitting at you.
It's just not happy.
No.
So likewise, it's going to the engine, same thing, making the engine not happy.
Right.
So bigger is not always better. You mentioned that earlier.
Bigger's not always better.
Very, very good. Okay.
Unless you got a huffer on top of it.
There we go. Then that's a game changer, right?
Yeah,
absolutely.
Put a huffer on it, you can do what you want.
Yeah.
Makes its own atmosphere.
So we're looking at the chamber here and short side. So if you don't mind here, kind of look. So what's as you come into on, you got nice radiuses coming in here, and can you explain what's happening here as air is coming in here? What does it like to see?
You usually put a wand in there to find out where the air comes in there and starts to push to one side or loads to one side of the wall. So the walls dictate how the air moves, basically.
Okay.
So if you got you got a wand doing this number and it's trying to push the air over that way, that means that the air wants to go over here. I really don't know how to explain it, to be honest with you. But one wall that has to be straight has to hang on to the air. Okay. And it actually pushes the air over to the other side to make the port flow right.
Okay. All right.
So that's why I say, one wall I like to keep straight, maybe a little bit blowed out on, one side. Not, when I say blowed out, not real big. On the other side, as the air comes this way, because it's trying to push the air over here, I blow it out so it does this number, comes out of the thing.
Right, because you're as you mentioned earlier, you're in smaller down here, so you got a larger volume here that you're having to squeeze down to a smaller area to pick up velocity to get it into the chamber.
Yeah.
Very good. Okay, so radiuses and so forth.
You know, that's a matter of preference to everybody.
Sure,
but I've learned that the bigger the radius, 3/4 inch radius or whatever, I just use a hypothetical number from a 1/2 inch to 3/4. The bigger the radius, they seem to make more power than the tight. Where everybody used to be real tight in here, we'd go in there and mark it out like the gasket, put a 3/8 burr in there, and then tighten that thing up so that thing almost looked like that.
Right.
And now you want them to look more round.
More round, okay.
For some reason, the air actually works better when it's bigger, rounded, more ports.
So you mentioned gaskets, right? So now we're moving up here in the system a little bit more. You have a gasket. So when I originally got this head, the ports were considerably smaller. How do you know where you want to put that whole location? Or if I'm have a stock head that I ran and I want to take it out and port it, where?
Well, your gasket's going to line up off the center of your bowl holes.
Right.
All right. Some of the gaskets don't always match up perfect.
Okay.
From the bottom or the top.
Okay.
Or the sides here. It'll be tight on one side and have a mile over here on the other side that you got to grind out. So
makes your job hard, right?
It makes it a lot harder.
Yeah.
Especially if you go to gasket matching.
There you go.
Because you can't go all the way down because you're only about 1 inch in, and you got to taper everything into it to make it work. So basically what I do is I get the gasket over there and I line it up the best I can over the holes, try to center it the best I can over the port and go from there.
Okay. All right. So we got the head done and we're going to bolt this manifold on there, but now how do we get the manifold to line up to the head with a gasket in between?
Good question. Best thing to do is to come in here and dike them.
Okay.
Right here and here. And what you're going to do is you're going to draw your lines up here off of this.
Right. Straight off the edge of the port.
Straight off the edge of the port.
Okay.
Straight across the roof.
This is after your head's done?
Yeah, after the head's done. Straight off the port to the side here because the manifold don't come out to here.
Right. Sure.
So you do it on both sides. Everything. So then you take your manifold and you put dike-em on this part of it. Let me show. I didn't want that to come off when I was holding it. So what you're going to do is you're going to dike-em this part of the manifold.
Okay.
All right. And then as you lay this thing up there like this, you already got your lines. So your manifold's bolted and you center it up where you need to. And then you transfer that line onto the manifold here and across this side here.
Okay. So it's obviously very important you use the right block.
The right block, the deck. Yeah,
everything,
whatever it's going
through. Gasket, everything that needs to be on
right.
Yeah. Oh, very good.
So that's basically the easiest way to do it. A lot of people, and I understand it, just put the gasket up there and gasket match it to and say it's good.
Right.
You can do it that way. You can cut the manifold to make it fit, you know, like, but that's the best way to do it. That way you get everything lined up.
Yeah. I remember some of the days when we used to roll heads and change this whole facing and angles didn't line up, and there's a lot of machining and milling.
A lot of welding, a lot of machining, a lot of rollover fixtures.
Those were the fun, the hard days, weren't they?
That's where your 18-degree cylinder head came from. The 23-degree head that we welded half inch or better on it from the intake side to nothing on the face to the exhaust side, and it was a 32cc chamber small block Chevrolet because we had to compete with the Fords with the C3 head, and that was the only way we could do it, and that's how we made the 18-degree chamber. How we made the 18-degree head.
Yeah, what we called the rollover.
Yeah, which was the rollover head, but it actually we rolled it over to 18 degrees. And that's how we came up with it.
Yep. So those are little tricks from the NASCAR side that we did years ago to get to where
you are now today with cylinder heads.
Very good. So
when you didn't have nothing to work with, you had to make whatever you had work with.
Yeah.
I mean, there's days, like you say, we can get into storage where we cut the center divider back all the way to here and made it like a razor blade. It didn't work.
we tried a bunch of stuff.
Yeah, that was on cast iron cylinder heads.
Yeah. Very true. So when the manifold, we can elaborate just a little bit. So you know, you kind of got the same thing going on here with the manifold. As it comes into the plenum, it's turning what would be considered to the short side here. So is same concept.
Same
of what you're trying
radiuses
to do.
make the big difference in everything. If you got a straight thing like this, you're gonna get air going by.
Right.
You got it to where the air comes in and can have something hooked to.
Yeah.
It's gonna turn. You know, a lot of the SP2 manifolds that we did and all, this side was down low and this was up high.
Right.
You know how we pulled them up like this C351 manifold.
It wasn't just a straight across.
No, this was raised up here.
Yep.
You know, all that. And everybody thinks sharper's better. Not.
So
you need a blunt nose down here on your divider to get the air to turn right.
Yeah. So the big thing is, takeaway is, you need smooth transitions, big radius stuff that the air can hang on to keep it moving. So it doesn't just jump out in space and just bigger than better.
It's just sitting there. It'll go there and have nowhere to go.
Right. Right. Very true.
You know. And if it's just sitting there, you got a big puddle of fuel here and you got nothing making no power.
Very true, because you have to keep the fuel atomized. So you know, then you come back to the finish of what you're trying to do with your ports. You know, is some people are like slick, some people are rough.
You know, we tried them all ways.
Yes, and
didn't find the difference between polishing them like a piece of jewelry or leaving them with like a finished burr that's not real rough. You used them big 5 flutes to dig out a lot of stuff.
Yes.
And then go back over it with a 12 flute or something like that and smooth it out. You didn't really make that much difference.
He doesn't care.
Doesn't care. As long as the transition, like you was fixing to say, is there, it's gonna work.
Give it something to hang on to.
But just don't make it look like cobbed up stuff. I mean, at least, you know.
We want to look presentable, right?
Yeah.
Yeah.
You know.
We want happy air.
Right.
There you go. Very good. Anything else you just
if you got snap gauges or something, try to make the ports as equal. The biggest thing, a lot of people make a port that's real big one, and then they think they got the other one, and you go and snap gauge it's off by 300 thousandths.
That's a huge difference.
Yeah, because then you got one port that's taking all the fuel, and one port that's getting lean that ain't getting no fuel.
Right. Right.
So biggest thing is take your time, pair of snap gauges, make them all the same as you can, and that's manifolds, and that's this bowl area down in here, the cross-sectional area by the guide.
Right.
Make all that the same. If you make all that the same on all the ports, it's basically the motor's gonna be the same.
Be the same. Make all your cylinders balance the same.
Everything balances out.
Yeah. Yeah.
But if you just go in here and match it and just start grinding and sit back here and look, oh, that looks, yeah, that's the same thing. I guarantee you take a snap gauge and stick it in here,
right,
you'll be off 100, 300 thousandths, and that's going to make a bunch.
So as many years you're doing this, are you still using snap gauges?
Right there, brother.
There you go. There you go. Spoken from a professional expert.
No.
He's been doing it for years, still using your basic snap gauge.
Actually, I go to, believe it or not, the easiest way to do it is like go to Harbor Freight or something, and what do you call them? Compasses or whatever they are, you know. What do you call them things? Man, I'm out of school. I've been out of school for 45 years.
You know the tool, though. You know the tool.
Yeah, it's you know what they got the points and you can open them up.
Or you open it up and get a measurement off of it.
Yeah, so what I do is I go in there and I heat them up and bend the gauges out.
There you go.
Bend the ends out, tighten up, and then I run my down through there to make the ports all the same.
There you go.
There's no line there.
The truth is there.
It's either going to go in,
yeah,
or it's not.
Yes.
And it's going to be the same, or it's not.
Right. Right.
So, yeah, what do you call them things, man? Protractors. There you go.
Very cool.
Get you them, bend the tips, make them square, grind them flat on each end, nice little flat, or you can leave them pointed, it don't matter. But you can walk in there from here down there, and you can, in so many, say you go a ½ inch in, take that port, make that ½ inch in this side the same way. Then go down another ½ inch or an inch. But use that as your tool, your guide.
Right.
Basically, that is your guide.
Right. Very good. So we're talking about keeping these consistent. So we're going to jump back here. So how do you keep your chambers so your compression ratio stays the same between all the cylinders?
Well, you have to pour them after each time.
Okay.
So after I get done grinding one, I'll come up with what I want. Then I'll go over there and start laying the other one out. And I'll grind it, and then I'll have to go and pour it and make sure it's the same.
Okay.
If I'm doing them all by hand. Now, you
Right.
know, if it's a CNC machine, you just do one the way you want it.
Sure.
And then you have them and it becomes equal. But if
Right.
you're doing it by yourself, you have to pour each chamber. And
Okay.
then you have to go back and look at, well, did I pull it out right here? Or do I pull it out here?
Okay.
Or behind the spark plug? You know, you have
Right.
to, you really don't want to screw with this too much. This side, if you screw too much with it, it gets real thin. Everybody used to undercut these real bad. That's where you got the Bernelling of the head gasket beating in there.
Right.
The old Felpro head gaskets with the stainless steel would beat in there because it bounces up and down.
Right.
You
think
think
you
you
got
got
structure
that head
support
torque
there.
You think you got the head torque, it don't.
Correct.
And you know the old small blocks where we had to pull water out of
Right,
here and
yep.
put water in it to keep this cool, so it didn't do that.
Those two exhaust valves together
Yeah,
were
so
just
when you
not
get them
happy.
too thin,
Yep.
like the old Ford heads, when you had to put the dog bone in here for seats, because you pulled so much out of the short side to get, because they like the line of sight.
Right.
It was real soft and it would beat the seat in the head.
Right. Oh, very good.
So
Awesome.
just it's trial and error. It's trial and error today.
There you go.
What
Well,
works today for me might not work for tomorrow.
It's a changing world. A lot of engines are changed, and understanding that engine and what makes that engine happy. Versus RPMs. Are you looking for torque? You're looking for horsepower.
And you know, these ports have been around for a long time. And you think you've already hit every angle, every scenario, every this and that, but I promise you haven't.
It's all the same till it's not.
Well, and I'm going to get off track here a little bit. Don't mean to be off track, but your camshaft design has a lot to do with how that port acts.
Oh yeah.
Because when I was doing stuff up there at Childress's, one head would work good. We had a basic motor, and that basic motor, we had our basic head, the basic motor, and we run everything across it. We knew what it made with the basic head design and basic.
Okay.
So same camshaft, same everything, and you had to make the next head better than what we had. Well, we did that sometimes, and the head was junk, so they would put it upstairs. Well, all of a sudden they come back with a camshaft change design, stick the head back
Sure.
on, and all of a sudden the head works.
You became a hero all of a sudden.
Yeah, you went from a zero to a hero.
I like those days.
So
The hero part, not the zero part.
that zero is a lot, man. There's more than the heroes, I can promise you. But anyways, that camshaft has a lot to do with the cylinder head design too. When they ask you flow numbers, it's for a reason. It's not just to see if you got a good head or make fun of you or anything like that. It's because you got to get the combination right.
Right.
You got to have the right cam for the right port, because you could have exhaust that's real shitty, so you're going to need a lot of duration, or you can have where the intake and exhaust are real balanced together, close. Then you don't need a big spread on the cam.
Yeah, so knowing what the cylinder head helps determine what camshaft,
Right.
or vice versa.
So when people ask you for flow numbers, it's for a reason. It's not just to make fun of, or you think that they're going to tell you, oh, you don't know what you're doing, your head sucks. No, it's so you can get the right combination.
Right.
And how many camshafts did we go through in cup days to find one that
How many a
works?
week?
How many a week? Yeah.
Yes.
Yeah.
Yes.
So it's a whole combination package.
Right, sure. Absolutely.
Like I said, what works for you might not work for me, and what
Understand.
works for me might not work for you.
Understand that. It's
But as long as we can skin that cat, we're okay.
There we go. Very good. Very good.
That's all that matters.
Anything else you...
Make sure your valve heights are the same.
Valve heights, right? So...
Make sure your valve heights, you don't want different valve heights. That's going to change your compression ratio. Not much, not little. I mean, a couple. Probably won't notice it, but you know, valve heights are very critical to the push rod geometry and all that. So
Right.
you got to make sure that your valve heights are equally the same within 5,000ths.
There you go.
If you can keep it all within 5,000ths, you're good.
Keep the engine balanced the best you can. Size of the ports, volume, valve job, how it's laid in there.
Yep.
Very good. All right. Well, Billy,
Don't be afraid to take metal out.
don't be afraid to take metal out.
You're going to get dirty.
There you go. All right.
So don't be afraid.
Well,
it ain't rocket science. It's just, you know, you got to go. Somebody had to learn somewhere.
That's exactly right.
I had to figure out how to do it sometime in
So
life.
the case in story is not everything is a success.
No.
You learn by trial and error.
Yes.
There's no great formula that says do
No.
this and that works. You know, stay out of the water.
Stay out of the water.
Stay out of the water.
That's a good thing.
And if you see if you're doing aluminum and you see the little dot, don't keep grinding on that
No.
and get rid of that dot, because that dot is getting
water.
water.
That's porosity.
Yeah, exactly.
You're
You're a little too
screwed.
thin.
Yeah.
I remember those days. I thought I'd grind some black spot out, and my black spot just got bigger, and
Then you're like, what do
I needed
do
help.
now?
Yeah, exactly. So very cool.
And if you can't weld, you're screwed.
That's why I had a guy.
I had a guy too. And he still does it for all the tough guys.
I know him. I know him well.
Yeah.
So, very good.
Yeah.
All right. Well, I appreciate it, Billy. Thank you for your time.
Hope somebody learned something.
Hope you guys learned something on this. You know, what some of the do's and don'ts of cylinder head porting, port matching. So I do appreciate the time. Thank you very much.
What a day, what a day, what a day. Yeah, my brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.